Hey guys, in this video I want to explain why object-oriented programming thinking is broken. When you think in an object-oriented programming way, you're thinking in terms of encapsulation, inheritance, and polymorphism. But what is encapsulation really? A lot of programmers think that encapsulation is just packaging behavior and state together within the same class, but really encapsulation has a lot more to it than just that. It includes packaging behavior with state, information hiding, and achieving business abstraction. Although mostly they achieve the first one successfully. Now take this piece of code as an example. You can see private attributes, but there is a setter and a getter for each of them. All getters, that is accessors, provide non-validated access, and all setters, also known as mutators, provide assignment without business validation. This is exactly the same as this piece of code. Providing public attributes has the same effect as setting and getting private attributes with no restrictions. This kind of encapsulation achieves packaging behavior with state, but it also makes you lose information hiding. And since validation rules are dictated by the business, you can't really have business abstraction. That's what we call broken encapsulation. Now let's consider why inheritance could be harmful. See, inheritance can break encapsulation within its hierarchy. For example, if a parent implementation changes while a subclass depends on it. Consider this example. You have a person class with a protected name attribute of type string, and this attribute is inherited by a class employee. There is a function called format name as string that depends on the name attribute being a string, and that is in the person class. By changing the name attribute to some other implementation, you will break the implementation of the format name as string method in the subclass. Another way inheritance can break encapsulation is by breaking the Liskov substitution principle. Imagine you want to build a case-insensitive string. Now, thinking from an object-oriented programming perspective, you will think it is a subclass of the string class. But think about it. What attributes distinguish this class? How is it different from a normal string? Can I safely say that a case-insensitive string is a string? If so, are they fully interchangeable in any given piece of code? Well, truth of the matter is, you could only see case insensitivity within operations, like comparisons and formatting of strings. In such instance, we say composition is the answer. And this is where the principle favor composition over inheritance comes from. Now, this drives us to conclude that thinking through object-oriented programming principles is not always helpful when designing a system, that is. And that is why we're learning design patterns from First Principles. Thank you very much for watching, and I will see you in the next one.